Hello everyone, today I'm going to show you how to get a start in driver development. We're going to be covering a few things, specifically virtual machines, setting up network kernel debugging, and also just some basic driver development tips. So we're going to start out with getting your IDE set up. So what you're going to want to do is open Visual Studio, and you don't want to open that, but you want to open the installer. And once you're in the installer, you want to make sure you have basic desktop development with C++ already kind of installed on here. Then after you get that, there's also some individual components you're going to need for driver development. Specifically, you're going to need the driver kit, so the Windows driver kit. Just check that box. And you're also going to need Spectre mitigated libraries. So you're going to want the latest for ARM. It's going to say latest on the right. And you also want the latest for x86-64, which is right here as well. And then just click modify. And wait for those components to install. Alright, and now that you've finished the installation of the Windows driver kit along with the Spectre mitigated libraries, the next thing you're going to want to do is navigate to this link in the description. Just pull it up right here. So first you're going to want to install the SDK, just right here. Let me get the installer. You just click install. It's going to say no. Doesn't really matter what you choose. So in terms of service, I'd recommend installing all of these. You technically don't need the ARM64 stuff if you are like x86, but I install it anyways, so. Alright, then you just wait for this to complete. Alright, now that that is finished, you want to go in and install the WDK, which should be on the same page, it's just right below. WDK setup. Oh yeah, you want to close the old one first. Now you can run it. Alright, just click next. Accept the terms. And wait for this to install. Alright, and once you finish the download on the WDK, you just want to navigate to the VMware installation page. I have a link in the description. Just click that to download it. And then once it is downloaded, you're able to install it. So when you install it, there should be two different players. There should be a VMware Workstation Pro and a VMware Player, which isn't going to show on mine because I got rid of the shortcut. But for VMware Workstation Pro, that's the one you do want for this process, since it does support snapshots. Those will be helpful later in the debugging process. So we'll just create a new virtual machine. I recommend doing typical, and we can install the operating system. Actually, we just set it up now. There. There's 11x64. Same as kernel testing. So I'd recommend setting a password that you can remember for this. I've forgotten my password a few times, although you rarely do need it. Alright. 64 gigabytes is a good size. We just leave it on the split disk. And let's modify a few settings. So I'd recommend pretty much having all of this stuff in here. So for my computer, I have an 8-core CPU, so I'd recommend just making a half of that 4. And then I have 24 gigabytes of RAM, so just make that like 12 gigs. And then you should definitely accelerate your 3D graphics. You do not need the 8 gigabytes. Right. Once that's done, you finish the process, it should automatically power the virtual machine on. Alright. And then once you're inside the virtual machine, this is going to be pretty much the basic Windows install if you've ever done a Windows install before. For VMware tools, I just remind me later for now since I can't install it yet. I just recommend going through the process, getting everything installed, and I'm actually going to fast forward this part, and then once it's done, we're going to jump back and work on the future steps. And this isn't necessary for the installation, but something I like to do with new Windows installations is turning off your network adapter temporarily while you're installing it, and then enabling this setting right here. Just press Shift F10. It'll open up this console, and type in OOBE/bypass NRO. When you press enter, it'll restart your computer, and this will disable the online account requirement. I think that's really nice for just not getting tracked, but it definitely is not needed. Alright, and then once you have the operating system installed, what I'd recommend doing is clicking the I finish install button, and VMware should try and get their tools installed on here. Let's see. Oh no, it's this button right here that makes it install. Okay. Then we'll just wait for that to download. Alright, and once those are installed, just navigate here and run the setup. Oops. Okay. And for this, the installation process is pretty standard. You just go through it, and once it's all done, you should be able to get hardware acceleration, which will make this so much more snappier. There we go, that is so much nicer. You already see it starting to work. It's not completely done. Now it is. And this is followed up by a restart. Alright, and once you're back into the Windows installation, you're going to want to open your settings. And I'd recommend getting your system all updated. So where are the updates? Oh, there it is. I'm blind. Okay. Oh yeah, probably should reconnect the Wi-Fi card. Alright, and then once the updates do show up, it's going to warn you it's going to take a very long time to install. So I'm going to time-lapse this as well. Alright, and then the next step I'd recommend doing is enabling network discovery on the host machine. So you can accomplish that by going to your settings and network and internet, advanced network settings, advanced sharing settings. Here you can enable network discovery and file and printer sharing. I recommend doing this for both public and private networks. And might as well just put it for all networks. And okay. And if you are doing this on like a laptop or a computer that you bring in public places, I would not recommend doing this sort of debugging, because it does make your computer more vulnerable to attacks. So once you have that, you can just do that. I wonder. Yeah, I can. Cool. Alright, you want to open your Windows Defender firewall with advanced security. We'll just close the guest for now. Specifically, you want to look in your inbound rules for file and printer sharing. Should be right here. make this just a little bit bigger. There we go. So for these rules right here, for the IPv4, we want to enable that rule. And it's the IPv4 for domain private, yes. Awesome. So I'm going to find this one right here, the echo request -icmpv4-n, and just make sure that is enabled. And there's 2 here. I'd recommend enabling both of these. Make sure they're both enabled. I guess there's 3 here. Yeah. Make sure all 3 of these are enabled. Okay. Then you should do the same thing for the guest computer. So let's go back into our VM. We'll open our settings. And let's go to network and internet, advanced network settings, advanced sharing settings, and then enable network discovery on both public and private networks. Might as well enable public folder sharing too, although I don't believe it is required. So let's run wf.msc, which will pull up our network and firewall rules, and then we'll go to inbound rules, and let's look for the same thing, file and printer sharing. Okay. See this one, it's not on. You want that to be on. Oops. Enable rule. I want to make sure all IPv4 ends for the echo request are all enabled for file and printer sharing. Public, private, and domain. All 3 of these should be enabled. The green check mark next to them. Okay. Then for that, I'd recommend restarting the guest. Then once the guest does restart, you should also restart your host machine as well. Now that the guest is back up, I'm just going to shut them down for now. Okay. And then let's restart our host computer as well. Okay, and then once we're back up, we should find our guest. And let's get them started up again. Then once the guest and the host are both back online, let's open command prompt on the host. We might as well open it on the guest as well. So we're gonna try pinging, we're gonna try pinging the host from the guest and the guest from the host to make sure that they both are able to communicate with each other over the Wi-Fi network. So let's see. This right here on the left, that is the host name of the guest. And then on the left, this is the host name of the host. So let's start with pinging the host. Pinging the host from the guest. So yeah. Here we go. And it does look like the ping did go through. Now let's try ping-4 using the guest's host name. I'm going to try pinging the guest from the host. Awesome, and this is a good sign. That means that both the guest and the host can communicate with each other over a Wi-Fi network using the name of each other. The next steps would be installing the SDK on the guest. We do not need the entire SDK, just the debugging tools part of it. we can ignore the WDK and Visual Studio. We only need the SDK for this. Okay. Next. So we do not need any of these except the debugging tools for Windows. So we'll install. And then we will wait for that to install. Alright, and now that the Windows SDK is done being installed, specifically the debugging tools, we can close out of our browser and we should have a specific path available to us now. So still in the context of the guest, we want to check if this path exists, and I will put the text in the description so you can just copy paste it into your VM. Okay. Let's do this instead. CD. Alright. And then once you're here, you type kdnet.exe. It should tell you that network debugging is supported on your NIC. And this should always be the message you receive since we're doing it through VMware and the guest always uses the same network adapter. So what we could do next is we should choose a port. So the port can be anything within the range of 50,000 to 50,039. For me, I like to choose 50,027, but I have seen other people choose different things within this range. Pretty much anything in this range will work. So what you want to do next is open command prompt on your host computer and copy your host name right here. Control C that. And then go back to the guest while you're still here and type in kdnet.exe, your host name, and then the port you'd like to choose. So for me, it's going to be 50,027. Then press enter. Then after this, you should get a string right here. This string is super important. I'd recommend keeping it in a safe place. So I'm just going to copy that out. And I put it right here. Then now that is done, just follow the instructions that it gave you. So you want to reboot the computer using this command. And then once that's rebooted, we should be able to access it using WinDBG. If you haven't already noticed, WinDBG was installed by default on your computer when you installed the Windows SDK. Although this is an older version, I recommend upgrading to WinDBG Preview. It might not be a preview anymore, but this is the newer version. So you can just search WinDBG download and download it directly. Just click install. And then while that's installing, let's check on the guest. And it looks like it does want to work on some updates. So let's let both of these processes complete. That took a much longer amount of time than I thought it would, so I just cut the video. I was originally going to time-lapse it, but I just cut it instead. So now that that update is done, what you can do is just go to attach to kernel, and then we'll grab the connection string that the debugger gave us and put it in the key field. Then before you do continue, just go to that port number and change it to the one that you chose. In this case, you can see I chose port 5027, so we'll just make it match that. and then I like to have break on connection on, although you do not need it, it just is helpful. If you press OK, it should connect in just a moment. If you do see this, this is totally fine. It just means that sometimes it's struggling to connect. But once you are connected, it should break, and then you are now attached to the guest's kernel. So you can just click continue, or not continue, but go. You might have to click this twice because it breaks twice sometimes when you connect. And there you go. Kernel debugging is all set up. And I'm just going to clear the output. If you ever did want to stop kernel debugging, you could always just detach. And then just reattach the kernel using this. This string should work anytime you're connecting to it. Alright. And then there's one more thing I wanted to cover related to this VM software specifically. It is with the snapshots feature. So, as you know, whenever you experience an error when making a driver, or an exception is thrown, pretty much any error at all, the operating system usually will blue screen, and that takes a very long time to recover from. So what I recommend doing is putting your project files on your desktop and then creating a snapshot right before you run your program. So you can do that by opening the snapshot manager, which is located near the top left, and just click take snapshot. We'll just do, or here, how about we make a change? So let's open command prompt. And then notepad, and we'll just say, this should be included in the snapshot. Okay, and then let's create that snapshot. Just call it base snapshot. And then we'll wait for that to complete. Alright, and then once the snapshot process has completed, why don't we... Oh, and one thing I wanted to say is if you do create a snapshot while you have a kernel debugger attached, there's a chance it could kind of break like this and you can't really interact with anything. You can fix that by just going to File and then reattaching to the kernel. Then once it is reattached, you should be able to interact with the guest again. So this is included in the snapshot. Why don't we do this is not included in the snapshot, and then we'll just say this is not included in the snapshot. So let's say we run our driver and it blue screens the operating system. So normally when the operating system blue screens, you would have to basically go through the error process. It takes you to the blue screen, and then it takes a while, collect its bug report information, sends it to Microsoft, and then it'll put you back in your operating system. That takes a long time. That could take 3 to 5 minutes, and that's pretty inconvenient if you're doing that every single time you encounter an error. So let's say right now we blue screen. Instead of going through that annoying lengthy process, we can just go back to our base snapshot and then go to it. This will load the snapshot, and it should be like that blue screen never happened. Alright, we are back, and this is the information that was present in the original snapshot before we did modify it. And this is pretty convenient because of the blue screen thing. So this, coupled with the kernel debugger, will make your life so much easier when you are making drivers. Then the last thing I did want to cover is the actual process of making drivers. So why don't we start that? So in making drivers, let's use the Visual Studio IDE, which should be already pre-configured for making the drivers, or at least in the earlier steps. So once we have this open, let's create a new project, and we can do KMDF kernel mode driver. Let's do an empty KMDF project. And then let's call this our test driver. And I'll just put this on my desktop for now. driver. Let's make a main.c file. Okay. And before we do continue, there is a few settings that I did want to, or I guess I would recommend putting on your driver project specifically. Those would be first changing the enable C++ experimental standard libraries. You do not want this. You actually don't want to use any standard libraries in C++ because these are not implemented very well in the kernel. They have very bad support for that. And then for the C language standard, you could leave this however you want, although I like to put it on C17, and for C++, I like to put it on C++20. And then for advanced, you want this to compile as C code. My reasoning for this is because C++, like I said before, it just doesn't have very great support in the kernel. There's many things that you can do to kind of shoot yourself in the foot and not realize that you're doing that when you use C++. So, just compile as C code. We could leave this on std call, although I've seen some people put it on fast call. It doesn't really matter performance-wise. The compiler's going to optimize most of this away for you anyways. So, and let's go to optimization. So you do not need this, but I like to keep this on just for speed. I like to put it on max optimization, inline any functions, and then intrinsic functions. Always want to favor fast code. And then just leave it on no, and yes on whole program optimization. Then let's go to code generation. So if you're using a manual driver mapper like KDMapper, I'd recommend turning this off. And for control guard, I'd also recommend turning this off as well. For the floating point model, I'd leave this on fast regardless of what type of driver loading method you're using. And no on floating point exceptions. We do not want a hot patchable image. And I'm going to disable spectrum mitigations because I usually make drivers for KDMapper. But if you are using, or if you are making one that's designed to be loaded like officially through the Windows Surface tool, you should definitely enable this. Right, I think we covered pretty much everything in here. Yeah. Alright, let's go to linker settings now. So, treat linker warnings to errors. We do not want that. That's a very annoying setting. And then for inputs, I think we're all good on that front. Manifest file, we're good on that front. Debugging, system, we could just leave this on native. For optimization for link time code generation, I put this on LCTG incremental using the fast link time code generation. In advanced, you don't really have to do this for drivers you load using the service tool, although I would recommend setting this to driver entry. I mean, it's not bad, and this is something you do need to do for a KDMapper. Just apply that. Right. We've covered pretty much all of the settings you should use for your project. I'm also going to have a pre-built project in the description that has all these settings already preset. You can use it as like a template for building your project. That's what I would recommend doing, since these settings can be kind of burdensome to remember. But let's start with a driver entry. But before we do that, we need the headers. So let's include ntifs.h and ntddk.h. And keep in mind you can't use any user mode libraries in here, so you have to stick to the ones provided by the Windows kernel. Driver. So we're going to take in a pointer to the driver object and a pointer to the registry path Unicode string. And we'll just return status success because it doesn't really benefit us to do any error checking. And then there is a cool little quirk about the different driver loading mechanisms, specifically if you are using the surface tool. A lot of tutorials omit this, but this is actually very important for like rapidly prototyping your driver. It's assuming it doesn't encounter an error. You want to have a function that handles the loading of your driver. You can do this inside the driver if you like. I like to kind of abstract this away a little bit because I'll switch between stuff like KDMapper and normal driver loading. I like to be able to comment it out in one line, so putting this in a function makes it just so much easier. Driver object, driver unload. We need to define a driver unload function that takes in the driver object. Right, I'm not going to write anything here for just a second while we work on this one. So we're going to want to complete a Unicode, or not complete, but create a Unicode device name. This could be pretty much anything. I'm just going to call it code Unicode. If I could spell this right, RTL encode Unicode string. Oh, no, it's RTL net Unicode string. That's what it was. And just make this a wchar and device name. Right. Just gonna call this test driver. Then and for these parameters, you don't really have to know what these do. You can look these up in this function's documentation, but I just leave it like this because I really don't do a lot with these drivers objects, or with these driver objects. So. False driver object, and this will basically create a device you can use for deleting your driver through the scan tool, which is super important for loading it using, or not scan tool, the service tool. Then in this one, now that we've actually created a device, we have to make sure to clean it up when we're done using the driver. So we're just gonna take in the driver object and then get its device object, which is part of the driver object. Alright, should be the basics for loading the driver. Just pass it the driver object by the pointer to the driver object, and then what do we print hello world? So for printing, I actually have my own little macros that I use. These make printing so much easier. I used to do it using just like debugprint without a wrapper and without any settings, and it caused all sorts of issues with just filters and stuff like that. So I use these two macros right here. So basically it takes your input and then it passes it through debugprint with some other parameters that prevent it from being hidden by your WinDBG. This will show straight to the output. So for print, we'll just print hello world, and then this is fun. How about address of driver object. Why don't we print the address of driver object where it's stored in memory? So we just cast this long to a pointer, not a pointer, but a 64-bit integer. Actually, yeah, why don't I just do this? Wait, can I do this inside? Oh, you can. Okay, this is so much easier. Okay, we'll use printf for this because it's taking in the string and the variable. So this will show a error, but it does not matter. You could just ignore that. If anything, I'd recommend putting this error C6066 in your error ignore list because it doesn't do anything. It just is annoying. Alright, now let's build the solution. Treat warnings as errors. Let's get that setting. Okay, I think it's in the linker. Yeah, wait. No, that's linker. How about let's try C++. Treat warnings as, there it is, it's C++ thing. So we don't want C++ errors or linker errors to be treated as errors because that doesn't matter. Alright, now that we have the test driver built, it should be in RX64, debug, right here. This is our driver that we want. So let's go to the VM that we created earlier, and we have that snapshot still. Oh. Save. Okay. So let's see, have we made a shared folder yet for communication? We have not, so let's just always enable for the folder sharing, and we also want to map it as a network drive in Windows guest. This is very important for recognizing it. So let's go to our desktop, if I could find it. There you go. That was not our desktop for some reason. Okay. Test driver, let's go to the build folder and debug. Let's call this test driver. Enable to share. And this should be recognized as a network drive now. It is. Awesome. And let's just create a link on our desktop for easy access. And we'll just call this test driver build. And whenever you open this, it should redirect you to the test driver, or at least the build folder of it. So let's pull out the test driver, and let's start building a, have a command right here to do that. We're not building it, but just for the surface tool, we're creating a surface. So it looks basically like this. These commands will also be in the description. You don't have to memorize these. It's just easier to write these down. I recommend writing it your own way to kind of like accommodate the path and the driver name. So we're just going to call it this test driver, and we'll call this test driver, if I could spell, and let's see what the path of this is. Okay. Let's paste that path in, and test driver, test driver.sys. Okay. Okay. And then as you can see, this is actually two commands in one. This creates the driver object, and then we'll start the driver. So before we do that, why don't we get our WinDBG open so we can actually see what the driver prints once the driver object has been created. going to use the same attach thing as before. Give it a minute to attach, and then we'll ignore these breakpoints. Here we go. We now have the kernel debugger attached. Just going to leave this over here on my second screen, and let's run this. Oh yeah, I probably should have mentioned you need to do this through an administrator command prompt. So let's elevate this, and then we'll run it. Awesome. And I haven't disabled driver signature enforcement or the driver block list, so it's gonna take you through the debug service every time you try and load a driver using the scan tool that isn't signed, like this one. You don't need to disable it, although it can sometimes be useful if you don't have a kernel debugger attached. But if you have a kernel debugger attached, it's just gonna send you through this debug service breakpoint, and then we'll let you load it anyways. So, oh look, there we go. Printed hello world along with the address of the driver object. And let's see. Yep, exactly as we expected in the output. All right. And there's one more thing I did want to cover in this tutorial specifically. I haven't seen a lot of tutorials that show you how to create a driver using KDMapper. So it's slightly different, but I'm pretty sure, let me see. So this code actually is not going to work as expected if you try and map a driver using KDMapper, because it loads the driver using manual mapping, and you aren't able to create a driver object because you don't get a valid driver object here or a registry path. Both these parameters are null. So this function right here, if you call it from a KDMapper driver, it's going to blue screen your computer. It's going to give you an access violation. So you could just set that to be commented out, and this will work without any errors with KDMapper. So why don't we put that to the test? Oh yeah, and with this driver, there's one more command I wanted to cover, the unloading of the driver. So this is small to where we can just type this out by hand. sc delete test driver. So basically that is two commands, just like the creation and run. This stops the driver and then deletes it. And the reason that these work is because we created a driver object in our test driver right here. Without this driver object, this would just be unstoppable, and we'd have to restart the system to get it to be destroyed. Anyways, let's comment out the load driver and build that solution. Alright. And then why don't we get KDMapper off of their GitHub? Okay, just download the zip, and then I don't know why I have that open. Mapper zip. Okay. I trust this. Okay. So we should just be able to put this on release and then build the solution. Alright. So we now have a working KDMapper release. Oh yeah. And with KDMapper you have to be careful to turn off your antivirus. They really do not like driver loaders. They get very mad about this. So we'll allow that through. And then okay, let's try that again. Still there. And then let's drag it to our desktop, our guest desktop. And your guest also is probably going to get very annoyed about this, so you're going to have to allow it through on your guest as well. I'm going to turn off real-time protection. all these protection mechanisms, we do not need them for testing. And we're going to, oh, alright, there we go, allow it through. And we now have KDMapper on our desktop. To run this normally, I should just tell you, please use parameters, so that's good. Now that we have our test driver, we did compile it earlier in test driver without the load driver, so it's all built. So what we're going to do is we're going to go to that network director, or that network drive, and drag that onto our desktop. And am I crazy, or where did KDMapper go? Did it delete it again? It did delete it again. Like I said, it really does not like KDMapper. Restore. Really does not like it. Did it turn itself back on? No, it did not. Okay. So to load drivers with KDMapper, all you have to do is you could either do it through the command line. In the command line, you just type KDMapper and then the directory of this driver to load it, or you can just drag it on top of the executable and then give it administrator access. Before we do that, I'm just gonna clear the output so there's no confusion. Okay. Alright. And then looks like an access violation did occur here. Did I forget to get rid of the load driver? Oh. Okay, so don't be stupid like me. I'm printing the address of the driver object, but KDMapper unreferenced does not actually pass anything valid through this function. So that was a very silly mistake. You're probably going to make a lot of mistakes during the driver development process. It's okay, because we had this VM set up so it doesn't blue screen our actual computer. So why don't we just print something else funny instead? So let's just do, let's define an integer that is cool integer. Make this 44. And then let's print the address of cool integer along with the value of cool integer. Okay. And why don't we also add some new lines so this doesn't look like garbage. There we go. Hello world. Address of cool integer. Wait. No. Address of cool integer. Value. Cool integer. Wait. Nope, I'm getting it all mixed up. There we go. Value of cool integer. Address of cool integer. Okay. And then let's rebuild that solution. And how convenient. So let's find our debugger. So this is actually what a error would look like if you encountered one in KDMapper. It's not going to give you anything useful. The stack trace is going to be all garbage with no symbols. So what we're going to do to recover from this is we're just going to switch back to the base snapshot. And then that'll take just a moment, but this is significantly faster than restarting your computer and having Windows fix everything for you. And this kernel debugger, it's not going to work after you switch back, so you're just going to want to stop debugging. Then you can reattach after the virtual machine has been restarted. Okay. DbG. So we're going to attach to the kernel. Let's clear the output too, why don't we? Alright, we're now reattached to the kernel. And it looks like we didn't save the progress from our previous steps. So just to not be redundant, since we already know how to create the shared folder, and obviously you'd want to create a snapshot after you create the shared folder, not before. but since we already know how to do that, we're just going to build this new solution, which does not print this parameter, which is going to be null when you map with KDMapper. Instead, we're going to open our test driver. We're just going to drag this in along with our settings. Whoops, that's my host computer. Settings on the guest. We're going to want to disable our antivirus. Oh. Sometimes you'll just randomly have your computer break into the debugger. So you could just ignore that. Just let it return to it by pressing go. So. That's it. Okay. So we got our KDMapper. Just gonna drag this back in. And it's likely gonna get mapped when you run it again. So we'll just have to reallow it. Yep. Windows does not like manual driver loaders, because technically these do act kind of like malware, which is fair. Windows. I'm so blind. Security. Come on. Does not want me allowing this through. Okay, why don't we just drag it back on? Okay, and now let's try loading that driver for real. So yeah, the test driver, I'm gonna drag it onto KDMapper, and then allow it through our UAC. And oh look, the driver loaded using KDMapper, printed hello world, the address of our cool integer, and the value of our cool integer, which is 44. Let's check the test driver, and it looks like this is alright. So that's how you would use KDMapper for your driver. And if you just wanted this to be a normal driver, you just get rid of that and use load driver along with these service creation tools. And that is the basics of driver development, both using KDMapper for driver loading or manual driver loading, and using the service tool for driver loading. Hope you enjoyed this video and that you learned something new.